Okay, good morning. Um, I will uh, illustrate a demo on it's a demo on Ohm's law. No? So our Ohm's law activity will involve the use of a resistor, a voltmeter, an ammeter. No? However, when we did it last time, what we used was we used a multimeter. No? We use a multi-tester, I mean. No? A multi-tester contains already the varied gadgets in our device. No? So it has a voltmeter and an ammeter within it. No? However, now this one is a better way to interact, and this is our FET simulator. No? And our FET simulator allows us to illustrate Ohm's law by choosing some gadgets here. No? We can bring out some switch. So a switch allows us to turn on and off our circuit. An on circuit like this, if we try to switch it on, if that's a switch, an on circuit is also known as a closed circuit. So we can turn it on and off. An off circuit is also known as open circuit. So other ways to show it. So this is a switch. We need a resistor here, and probably let's rotate our resistor. Now there's a color within our resistor, and obviously we can know its value if we are able to read this. So this is our resistor. Now we can provide ourselves with a battery. So this is the positive side of that battery. And we can then relate the effect of a specific resistance on our circuit. So a battery, a resistor and a battery with a switch, and then we can connect them by virtue of a wire. So let's make it a little bigger, our circuit. Let's move this up. So this is a wiring. So we'll simply attach it in a manner where we can have a bit of a space. So we are simply connecting our battery with our resistor. Okay, so this is now our battery with the resistors, with the wire, and let's complete our circuit. Let's add another one, but we have to include our switch. So we connect our switch to our wire, and let's have this one. So there's a switch there, and this time we have our completed circuit. Now our resistance, we can probably increase it. And you'll notice that as we increase the resistance, the color within our resistor changes. Depending on the value. So our resistor last time, we have a color code. We learned that one already. Okay, now if we will look at the schematic diagram, then probably this is how the schematic diagram would probably look like or appear. So it's merely the dots, the connections. So sometimes we call these dots as the nodes. Now, when we turn on our circuit, okay, let's say we start out with our battery. Let's provide it with some 12 volts. Sige mo, ito na lang ako na. 22 volts. So we have a 22 volt source and we have a resistor that is, so you'll start with a small value. Okay, we have a 12 ohm. No? Okay, can you record, Jason? So our battery is 22 volts.
22 volts.
Our resistance is 12 ohms. No? And our question is, how much will be our battery? No? Dalagay na a moment. We have now to measure the voltage across our resistor. No? So there are two things that we need here. We need a voltmeter and an ammeter. No? Now our ammeter is connected in what manner? How do we attach our ammeter? Jason, how do we attach our ammeter?
Series.
Our ammeter is connected in series, so therefore we have to align this. No? So that's our ammeter now. No? So if we remove this portion of our wire, then we can connect our ammeter there. No? Let's just straighten it, no, para it will look nice as well. So we have now our ammeter. Now our voltmeter is connected in what manner?
Parallel.
Voltmeter is connected in?
Parallel.
Jason, our voltmeter is connected how?
Parallel, sir.
It's in parallel. So this is the negative side. Let's connect it on this end. And we connect that on that end. No? Now we have not energized our circuit, so therefore we have no reading at all. How much resistance did we assign here? So we put a 12 ohm resistance. Now, since the resistance could be varied, no, then we can probably call this as a variable resistor. So, ang aton niya, the resistor that we are using, no, is a fixed resistor. No? The one that has labels there, no, that we buy. The one that you brought last time is a fixed resistor. This one, if we are able to change the value, no, to some specific value, then this is a variable resistor. Now, our resistance here, R1 is 12 ohms. Our resistance, our battery, I mean, is 22 volts. How much is our current and voltage? So let's switch on. Kindly record the value of our current. So our current now is
1.83.
1.83 no? ampere. Our voltage is 22. No? Okay. So that's for our first value of resistance. Again, resistance 1 is 12 ohms. Okay, now we turn off our switch and we kind of increase the value of our resistance. No? Let's increase it. No? Now, what do you think will happen to our current if we are to increase our voltage, no? Our resistance, I mean, what do you think will happen to our current? Kyle?
Masaka.
Sir.
Masaka ang ano? Current?
Increase in current.
Will our current go up?
Yeah. No, sir.
We now set our resistance to 33 ohms. Now, what will happen to our current? What will happen to our voltage? So, increasing the current, the resistance will result to a higher or lower current?
Lower.
Lower.
lower current. No? So now it's 0.67 amperes. Pila gani kayo na? How much was the first value?
1.83.
1 point.
83.
Okay, so this is a marked decrease. No? So nag 0.67 amperes is left. No? So we're trying to verify the principle of Ohm's law here. No? Okay, so this is for our resistance 2. And then we turn it off again. No? And for the last activity, we will try to increase the resistance again to R3. Let's say our R3 now is made 70 ohms. No? So there is now an increasing value for our resistance. No? R1, R2, R3. And let's try to switch on our circuit. What will be the value? Earlier it was 67. Current is 0.67 amperes. Now the current is just 0.31 amperes. Now our voltage is still 22. No? So that's the supply voltage that we have. No? Now this is happening because the internal resistance that we set, no, for our battery was not changed. No? But you'll realize that the battery itself has a resistance. So if you increase the resistance of the battery as the battery ages, no, you'll notice that the terminal potential difference or the available voltage that the battery can supply will now become smaller. No? This time, if the battery is getting older and older, no, the internal resistance is getting higher and higher. And as you increase the age of the battery and the internal resistance getting higher, the output voltage now becomes less. Do you follow?
Yes, sir.
Okay, so that's Ohm's law. So if there's no resistance for our battery here, then if this is 22 volts, no, then what we get is also 22 volts. However, if we make this higher, then still the battery may be 22 volts, but the output voltage is no longer 22. It's now only 21.39. Now again, no, this is what we term as the internal resistance of the battery. The battery ages, no, and eventually it will result to a lesser value. Now, let me flash now this is a dry cell battery, no? And this is what I'm referring to, no? When so this is a dry cell battery. No? Again, that was Ohm's law, and Ohm's law, we try, our objective there is to verify, no, the principle or the thing we call Ohm's law. No?